Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with learnbay.co. Happy learning!
We actually uh, we went through this mainly the three core categories. One is logistic regression, one is decision trees, one is random forest, and then we also talked there are other packages like XGBoost and LightGBoost, right? So if you remember, logistic regression is mainly categorizing is it churn or not churn using a logic function, right? So the logic function will give you the probabilities, and if the probability is maybe greater than 0.5, you will say this guy is going to leave, or if it's less than, you'll say no, he's not going to leave. Decision tree, if you guys remember, I've gone through that example with a tree structure where you will try to see few things on the route that if this user's monthly charge is this much, then you'll come here, you will see, and you go to the root node, leaf node, and then you will see if it is yes or no. Right? So that's the decision tree. And then you have a random forest, which is pretty simple. You have a lot of trees together. So the final answer will come contacting all of them. So you'll ask each tree how is the prediction. Towards the end, you will combine that, and that will give you the end result. Okay. So you have boosting, which is basically you will assign those 20 candidate trees, which is a good learner and which is a weak learner. Okay. So you will try to improve those learners through your boosting. So you will keep on iterating and make those weak learners good learners. Okay, towards the end you will take the decision. So how is this different from random foresters? Random forest will basically build certain number of trees, suppose 10. Okay, it will take the prediction. Okay, but boosting will try to make those 10 trees, identify them which is weak, which is strong, and then basically using those metrics, it will give you a better accuracy, right? So it knows, okay, for this sort of data input, I'll go to this tree for the.
This is how black box testing.
Sorry,
this one boosting also black box technique.
Yeah, it's basically same. There's a random forest with boosting as a on top of that to make it more better. Okay, we'll see.
Pick up the strongest trees and
ignore the right. So the decision trees are prone to overfitting. So overfitting means in the training data, suppose you have 100 as your data set, 80 is training, 20 is testing. So what this decision tree will do is it will try to learn that 80 very good, right? It will remember it. But when you go to that 20 test data, it will fail because it remembered 80. It should not remember, it should learn the pattern, right? When it learns the pattern, it will do well on those 20 also. So that's the main problem with decision trees. So they overfit. So you need to prune them. So pruning is like in a garden, you cut those extra things, right? So similar to that, you need to prune them. Okay. Then you will apply boosting, bagging, all those techniques to even get better and better. Okay, so we talked about accuracy, precision, recall, F-score, right? So accuracy is how well your model is doing. So out of your model accuracy is 70%, you are saying out of 10 predictions, 7 will be right from the model. Precision is basically, this is a classification problem where you have true positives, false positives, true negatives, and false negatives. So basically precision is basically how many of them are true, right? So then you have recall, then you have F-score. So these are all the metrics that you would see to select which one among those. So you have so many options now. So which one would you consider for what? So that basically is mainly evaluated using these metrics, right? So now we'll go to the code. I hope you guys can see the text. Yeah, I think this is good enough, right? You guys can see what is happening. So here, you guys are familiar with Jupyter, right? Right. So here you can write text, you can write Python. So this is basically a Python 3 kernel. On the right, you can see this is a Python 3 kernel. The dot basically means nothing is running right now. It's just ready to be run. You can see it's organized in the structure of cells. So you have a lot of cells. In between, you can also have pie chart on the visualization that you can have. Towards the end, you will see that one second. Yeah, towards the end, we will see the precision and recall curves, right? How is each model doing with each, what are the different patterns? Then over here, you will see the confusion matrix, right? So how is the true positives, how many are false positives, right? So over here, you will see the model performances. So this is a very important, plot where you can see that you can plot everything, accuracy, recall, precision, and F-score for these guys, right? Now you can see that the recall for SVM classifier, this guy, right, is 0.80. With RBF kernel, it's 0.51. Right, you can see that recall score, which is 0.51 for this particular model, which is SVM classifier using the kernel, which is RBF, real basis function. So you can get a clear understanding using this plot what is happening with accuracy, precision, recall, F1 score, right? So using this, you can at the end select which model you want to go with, or you want to do 2-3 models together as an ensemble. Or if your business applications, like you want to not give any false positives, right? Your accuracy should be really high. Then you choose one model. Your business is okay with few false positives, but they want it really quick and they want it cover the churn really well. They want to make sure the churn is also. So point being, even if you're not going to churn, I can give you an extra offer. It won't hurt the company, right? So that is basically false negative, where I'm telling this customer might leave, but in fact you're not going to leave. So Airtel will come and tell you, hey, you know what, I'll give you 10 GB data for 1 rupee. You're like, okay, fine, doesn't matter. But what if you lose a customer, you tell that this customer is not going to leave, but the model says that, the reverse, the customer is going to leave, but the model says, no, he's not going to leave. So you ultimately lost a lot of money, right? So based on those metrics, we will see how we can choose for which problem, right? It's a pretty long code, so I'll share with you guys this code. So maybe you all can experiment with it, try to see if there are any errors. So this is just a text, so there's no point. So I'm using basically NumPy, right? There's pandas, and then OS is basically to get the file path. Like suppose the data set with me is in this computer, right? So that's how I'm using OS. Then there is other matplotlib you might be knowing, right? Basically for plotting all those images. So what else? So you have iter tools, then you have pandas. So pandas, NumPy, and what else? Plotly. So these are the main important packages that actually are very necessary. Okay. So PIL is for image, right? So PIL is for meaning image processing sort of thing. Right? But I don't know if it's being used, but that is there. So mainly,
what is the difference between matplotlib? Because for visualization also we are doing matplotlib.
Exactly. So I'm using this thing, plotly. So this guy is actually very powerful. Like I'll show you why. So here I can actually download it as PNG, edit in Chat Studio. So there are a lot of powerful APIs with plotly. So whatever you can do in matplotlib can be done in this with better visualizations. So I'm not really sure how we can do this in matplotlib. So for this particular thing, actually I felt these are really nice plots. For example, you can see here the 3-dimensional one. Definitely you can do the same thing in Matplotlib, but see this one, right? So it's very intuitive to visualize, right? So this 3D ones are really helpful in this package. Okay, so this 3D one, and you also can see this one. This you can get in Matplotlib also, but the idea you get, right. So you can do the same things, but it has 2-3 better extra 3-dimensional plots where I can see 3 things at once. Okay, so I'll just go through from the beginning. You have this. So I hope right now you guys are familiar how to read the data, which is the first important step, right? So unless you read the data pandas as PD, and then I have a CSV file with me, which is .csv. So I'm just doing pd.read.csv, the file name, right? So this file is present in this directory where I'm loading this. Suppose it's in another directory, just give the full path, like /home users, your name, downloads, or if it is just in this current directory, just give them. Okay, so you will just see the head. So head by default gives you 5 rows, right? The data set might be very big, right? So head basically is just like you're just trying to see the head of this data. So in this data frame, so we have already made this data as a data frame, right? When we did that, the word has to change. We are not using data now, we are using data frames. We are working with data frames now, right? So you can see the column names, just see the sense of data, like what is it. So you can see that customer ID is a unique identity, anonymized per client. So whatever the data he gave, he used some technique to anonymize it. Then on the gender, you can see if it's female or male, senior citizen, 0 or 1. So 0 means he's not a senior citizen. 1 means his partner is yes or no. We have a partner. So basically, whatever I've described just a few moments before. So you can see here the multiple lines. All these strings have to be changed to yes or no, right? So we can make it simpler to 0 or 1. But first step will be we will remove those no internet. Remember, I showed you that I'll replace the no internet with just the word no. Then the model will be understand. It's simpler to work with and instead of this big string. Then you will see the types of internet service. Is it DSL? So if you guys are remember, the phone which goes into that is DSL. Fiber optic is these ones, the latest ones, right? So online security, did you opt for online security from this particular service provider? So like this, you have a lot of columns, and then you can get a sense of data, right? So yes or no. Streaming movies, what is the contract? So month to month or 1 year. Then you have paperless billing, payment method, monthly charges, total charges, and so on. So if you look at the data overall, so last 3 fields are very important, right? The amount of you pay to that. In the beginning, the tenure is important, how long you have stayed. Remaining are just demographics, meaning like your age, gender, what is the type you pay. The way you pay the bill to the customer might not be a really great feature, right? It's just you leaving the service, you leaving Airtel versus the Airtel giving you online option is not so strong predictor, right? But you leaving the service because the plan itself is costly is a very strong predictor, right? So that's why in that I shown you plots because of these last 3 categories. So in this we will see a plot for everything. So we will get to see how each column is compared to the data point. So you have 21 rows. How is this connected to this? How is this connected to this? How is this connected to this? In the presentation, I've shown only the last 3 because they are the important ones, right? So any questions? I think it's pretty clear, right? Pretty straightforward. So we'll just see this is pretty important step, I believe, because whenever you're working with data, make sure that the data, you have a sense of it, how many rows, how many columns, are there any missing rows, missing columns, because the model will not understand what NaN is, or it needs to be removed or replaced with some value, right? The age is, for example, enumerate 23, 24, right? It cannot be high. The age cannot be high. You can wonder why high will come in age, because the data that I'm populating might do error, right? So that's where the error might come. So you need to make sure that these data are not there. One more point is what happens if this data is somehow you missed, like somehow it is hidden somewhere and you forgot and made a model. So model will try to fit that also, right? So you have a data, nice data which is clean and numbers are there. Now there's a data points here, few where the model is not able to understand that, like it will try to shift that also and fit that also. In fact, these are the things which should have been removed in the first place because they are wrong. The way they have collected have been the wrong process, right? So that is very important. And one more thing is sometimes the columns will be empty, right? In the data processing, I've shown you that few of the cells will be empty. So we should make it that 0 or mean or using central limit theorem, what is the average, whatever technique you works, you can actually do that. Don't keep it empty, that's the point. Basically replace it or remove the whole row. Suppose out of those 21 columns we have, out of those like only 2 are present. It might as well you can remove the whole row because there's no data, right? So those are the steps that will happen in the next. So here you can just see, so I think you guys are familiar with these notation, right? So telecom.shape of 0 will give you the number of rows, columns. Features is basically toolist. So what does toolist basically do is, suppose you have some another data object where you want to make it a list, right? To create a list out of something, which can be done in a string to list. Yeah, something like that. Yeah. So anything, it doesn't have to be string object. Any object which can be called toolist will be, converted into list. It could be pandas, it could be data frame also, you can make a list, no? So that's important. So you can see the number of print missing values here. So good that we don't have any missing values. So that's good. 0. Simple analysis here. You're just seeing how many are unique, right? So what are the unique values, right? So gender unique, whatever. Right? Technically, there are only 2, male or female. So in tenure, you have 73 unique values, right? So 3 months, 6 months, 7 months. So like that, there are 73 types of tenures that users have given. And you can also see there are how many 7043, so 7043 rows that we have. Among those, people have stayed in varieties, like some guys stayed for 6 months, some guys stayed for 60 months. So like that, we have 73 types of unique values. Right, so like that you can see all these monthly charges. You have 1585 and total charge you have, because it's a number, right? So 10 rupees, 11 rupees is a different category. So that's just a simple axis, and then here you can see the data manipulation, right? So the important step that I've told, if there is a NaN in the data, when you do pd.read CSV, you will basically end up with NaN if there is no data. I'm just trying to replace that with empty. Right, so replacing null values in the total charges column. So this line basically in the total charges, okay. I think after this I will remove, I think. Yeah, see, in this line I'm dropping that. First the NaN, what I'm doing is the NaN value in that cell in the total monthly charge, I'm replacing that with empty. Then I'm basically removing those values, so not null. So I'm just, first I have some NaNs, I've just replaced that NaN with null. So I'm just working with the values which are not null. So I'm just ignoring these values and getting hold of the values which have actual number. So this is the line you can see here, where it will basically remove that NaN values. Any questions, any doubts? All right, so I can just go ahead. So basically I'm doing the reset index so that that stays there only, to whichever the column it stayed. So basically it stays there. So here, as I mentioned, if you do not have an internet service, all these columns will have no internet. So your online backup will be no internet, streaming TV will be no internet. What I'm doing here is I'm going to each individual column. If it is no internet, I'm just replacing it with the word no, right? Pretty straightforward. So in case of senior citizens, I'm doing this yes and no as 1 and 0. Okay, if you're a senior citizen, and basically the value with yes is replaced with 1 and the value with no is replaced with 1. So you can ask, why is this done? How is it going to help? So technically it's just label encoding or encoding form. It's a practice where you will work with ones and zeros instead of strings, right? So the model will be having a, technically you should give everything in ones and zeros so that the model will work with numeric values most of the times. But the decision trees you can give yes and no, but I would advise you to give that yes and no to ones and zeros so that it can actually work faster, right? So what I'm doing here, can anyone tell me what I'm doing here? This function is pretty straightforward.
Bucketing the tenure.
Right. So what are the buckets I'm putting? Right. So if it is less than 12 or equal to 12 months, I'm putting it in tenure underscore 012. So it's pretty clear, right? So are you guys familiar with lambda functions? On the line, last line after return, here, the highlighted part, what is happening? Can you tell me? Are you guys familiar with apply of data frame? Yeah, I'll just unmute you. Can you guys unmute yourself and then where is Srikant? Srikant.
Yeah, hello.
Yes, Srikant. So what does it do? Maybe you can share with us.
Yeah, so basically it is instead of making a function by by writing the definition as we do in Python. So using lambda also we can make a function and use it with inline, and using apply we can apply it over the data
frame.
Yeah.
Yeah, exactly. So you can create a function technically, but you want to have use and throw functions at on the run, right? So this tenure function, you will not use it again. Once you are done with it, once you have binned them, once you have bucketed them, you will not use it again. So you will just build one function on the fly, which is a lambda function with some input, and then dot apply is basically you are applying this to all the rows in that or whatever the criteria that you have, right? So I'll just go back to that slide. Thanks, Srikant. Where is that? Can you guys see this? Just let me know if you guys are not able to see that. I'll just share the screen. So moving on, you have this. I think it's clear right now. So what is lambda? Why are we using apply? So here we are applying to that tenure group, right? So we have a new column now. Before we had what do you call duration, which was monthly, which in fact became as tenure now. Is it 0, 1, 2? Is it 12 to 24? We also talked why we are doing this. Anyone can repeat that? Why we are doing only 12, 24? Why not 5, 6 months?
1 year.
Yeah, exactly. Because the business consideration that we had, because companies generally give in US or maybe in India, I don't know, that 1 year plan will be free or will be 50% off. So that's the main reason I'm doing for 12 months. Had it been 6 months, I would have made it buckets of 6, which would be like 10, extra 5 double buckets. And below you can see that I'm just creating 2 more data frames, which is churn and not churn. So you can see what is happening in the data frame telecom when the column name of churn is yes, right? That is basically I'm putting that into churn. So in the big data frame called telecom, I'm going and looking at the column name called churn. If it is yes, I'm taking all the data points and putting it in churn. Similarly, I'm doing that for not churn. So we'll see why we are doing this, because we can get correlations between churn and not churn and all that, right? When you want to make plots only for churn, so this would be really helpful. So you would make a plot only for that churn data frame instead of that big data frame. I'm not interested in that. Suppose I want to make a plot for only that, then you can use this. Okay, so that's a pretty straightforward step. This step is mainly a sort of a bookkeeping step, you can say, where as you can read, it's separating categorical and numerical columns, right? So what does numerical and categorical columns mean? So categorical is a gender. It's a yes or no. It can't be one, right? Gender can't be 1, 2, 3. A numerical column is basically 1, 2, 3 or number, right? So what's happening here is so this is a, so in this target underscore column, right? So I have a list of column names that I know are target, that are categorical, like gender, internet service provider and all. So I'm just so are you guys familiar with list comprehension? Is it taught? I think it should be taught. List comprehension. So can you tell me what list comprehension is? No, that is list comprehension basically. So what is happening? Can you tell me? So it's similar to lambda, use and throw list. So you're trying to compute something on the fly, right? So that function, that line of code can be written as for x in category columns, if x not in target columns, create a list and add it to that. Instead of 3 lines of code in Python, I'm writing only 1 line of code. Any doubts? Any clarifications? I think it should, you guys understood what is happening in that line. Cat underscore columns equal to, there is a square bracket, which is basically a list in Python. And you can see x for x in category columns, if x not in target. It's pretty straightforward, even if you see it as English. So I'm just looking for the rows or the names which are present in categorical columns and not in target column. You understood, right? So you can actually explode this into 3 lines, or you can just write it in 1 line. Any questions, any confusion? Wait, let me just check. So this basically is the number of unique. Okay, so I think the categorical thing is done in a different way. So what is happening is telecom.n unique will give you the number of unique. On the top we saw, right, the number of unique for each. Right? One was so okay, I'll explain now. Very simple. So we saw gender. What are the number of unique ways? 2. We saw monthly charges. What are the number of unique ways? 1500. Right? Monthly charge could be $100, $200 like that. We saw the total charges number of uniques were 73. Right? So here what I'm doing is, when the number of unique categories are less than 6, I'm trying to put them as categorical. That is the assumption I'm doing. Is that correct? Because gender will have 3. Gender is 2 only. Gender will have 2, but the category like monthly charge will have 73, which is greater than 6. So that will go into numerical columns. Categorical columns will be less than 3. Should have been less than 3, but I think there are 3 more. DSL, fiber, if you guys remember, one of those could have more than 6. So this 6 came from there, right? So that's a good question. So you can, I think you got a sense of now. So we found that we saw 6 is the maximum number of categories for different types of columns, right? Gender has 3, internet provider has 3, some other column has maybe 6. So whatever is below that, I'm saying they are categorical columns, right? That it makes sense, right? So there I'm doing a describe. So So describe basically gives you mean, standard deviation, minimum, then the 25 percentile, 50 percentile, and 75 percentile, and the max. So these are done for these two columns, which is monthly charges and total charges. So describe will not work on categorical because min max is what? Male and female. Like it doesn't make sense to find min max in male and female, but it makes sense to find min max in numbers. What is the minimum of 1, 2, 3? Minimum is 1, maximum is 3, average is still 3. 25 percentile would be maybe 1.5, something like that. You guys get the idea, right? So standard deviation and all that is given here. Now we'll come to this, the labels, the values, and the plots that we have, right? So the first plot is the one that I've shown you in the PPT, where we are not doing any complicated thing. We are just checking what is the percentage of customer churn that is given in the data. How many people are churning and how many are not churning. 76% were not churning, 24% were churning. If you remember that blue and green color plot that we showed in the PPT, that this code is mainly doing that. So you have the labels, you have the values, okay, and then you are basically going and creating a pie chart. Is this step clear? I think it's pretty. So you can, maybe if you have questions, you can ask me what is this royal blue light. Is this the color convention that I'm using? That is giving me a plot, the pie chart, right? So you're having hover info is basically label plus value plus text, right? What is the label? Churn. What is the value? Maybe 24%. What is the text? Maybe. You can actually see that and here. So the value here is yes, people who have churned, and the number is 1869 out of those 76 we saw in the beginning, right? That computes to 26%. I think this is pretty clear, right? Next, we'll move on to the customer churn, the variable distribution and customer attrition, right? So I'll just go through the plots first and I'll come back to the code. So what is happening here is, now we have 21 columns, right? Last column is customer churn. The remaining 20 is gender, internet service and all. What I'm trying to see is derive plot between each of these with the dependent variable, which is churn, right? How many are male and female who are churning, right? That plot is given here. So you can see the blue is female, right? On the top, you can see the gender distribution in customer acquisition. Now you might wonder, why are we doing this? Because we actually came to know a lot of things just by plots in the first session, if you remember. That 1 year thing and a lot of money is being lost, 26% is churning. So all these are computed with the help of these plots, which will give you a nice analytical perspective where you can make a PPT and show your customer. Even before building a model, you have a lot of insights onto what is happening with your customer data, right? So this is basically, I'll just quickly go through this once and then I'll come back to the code. So this is basically comparing the female and male ratio versus churn and non-churn customers. So similar to that, you have senior citizen, then you have partner distribution, dependent. So for each column, I'm just trying to create a plot for the last dependent value, right? Sorry. So we also, so that is the first. So we have a function here. Okay. So I'm creating a generic function called plot pie, right? So this plot pie will be called for each individual column. Instead of writing code for every column, I have a generic column. I'll pass the column names which I want to use, creating the plots. I will compare this column, the data, and that column, the dependent column churn, and then create a plot, pie chart, right? So that is the main idea of this code. So this is basically, you can see what is happening. Similar to that, I'm getting the values and I'm making a list, and then I have a hover info, which is basically exactly similar to the top one, which is the which will give me all the pie charts. So here I have a histogram function, right? So this is again, if you go to the bottom, we have seen the pie charts now. You will have 20 pie charts. After that, you have a histogram. So here you can see the category number is 4, right? We were wondering why is that 6 number, right? So this guy has 4 types. The types are 4. Payment method has 4 types, right? So that's how we came up with that number 6. Now this is basically our what is that, histogram. So here you can see the distribution. So pie chart, you get the percentages of how much of the pie is occupied by which guy. Here you can see how much of the length, basically how high, how low, right? So the tenure, you can see among 38 to 39 tenure gap, which is the months, like 1.7 are non-churners and 1.44 are churners, right? On the right you have percentage. So basically 1.7% are non-churners. So I'll just go to 12. We'll get a great, really good understanding. So below this, you can see the numbers are staggering. Like you can see this blue bar in 1 to 0 month. I hope you guys get the idea what is happening. In the initial phases of the plan, customers are leaving very rapidly. So 11% of all the percentage of churners, which is 26, is just within the gap of 2 to 3 months. Right? You all agree with that? Why this plot is useful? What is this giving us? What help it is giving us? So, but let me go after 20. It's just boiling down to 1%, 2%, 2%, 3%, and then towards the end again there is 6%. Sorry, 0.3. Sorry, that is non-churn. The orange one is non-churn, who are still with you. The blue one is churn. So you can see the trend. Suddenly there is a spike in the initial months. Slowly it falls down and boils down and reaches converges to something. Right? So this is the use of this plot. I'm doing this with again every field similar to the pie chart. Right? So you can see here in the initial, when the monthly charge is maybe 20 to 24 or 30 to $31, right? So 0.7% are churn customers. But when your monthly is, let's see this big blue bar here. So you can see that when your monthly is between 70 to 71 dollars, for some reason they are giving. When your when your monthly charge, the bill that comes after the month is between 70 to 71 4.92 is this from these plots itself to go ahead and see how well your model is doing or what is happening with your model, right? So you guys understand what is happening. So towards the end, we have a scatter plot. So one of the important scatter plot, I have put it in the PPT, which is this one, right? I think I've already talked 2 times about this, so I think it is pretty explanatory. So if you want just one example, I'll give you. When the monthly charge is 69.9, right? And when the total charge is $4,615, the person has left. Yes is basically, where is the color convention? So yes is basically left. Customer has churn, right? So here you can see what is happening. So with this help of plots, you can compare. Now we have one more important thing that we figured is going to be a really good predictor for us, which was the 12-month tenure, which we did the bucketing for in the first place. Let's see how it is connected to our churn, right? So you can see here the customer churn, the blue color, is so high in the first bucket. Just see the blue colors. It drops drastically, right? And on the contrary, you can tell me, you can say also that the non-customers are relatively increasing, like the trend after the tenure 12. If you have stuck with them for 2 years, it is ideal to say that you're going to stuck with them for another 5 years, 2-3 years also. That's what you can say from this data plot, right? So that's clear. So if you guys want to go into this, it's pretty straightforward. Like that's why I'm not going through these plots, because we can go to the model. That's what this session is really about, right? I'll share this code with you so you guys can tweak it and see what is happening in detail. So similarly we have again, so this is a interesting plot. So monthly charges and total charges by tenure group. So here you can see when the monthly charge is 66, 134 is the total charge, and red means it's tenure. So this is just a plot between monthly charges, total charges, and further tenure. Like point being, suppose you have stuck for 5 years. So how was your monthly charge and total charge in the initial, and how was it been till the end? Like once you started with the service, and how is the plan has been serving you? Like you had a increase in your charge or decrease in your charge, or like is it just increasing? So on the overall, you can see that the charges are increasing for this plan. Like it's increasing. The plot is towards right increasing. I'll just skip these. So I think you guys understood why are we plotting these, right? I think it's pretty self-explanatory. We can just skip to this part where we are doing the model prediction. So here I think last time someone had some doubt, how does this 3D plot work? So here the color convention is that if you are red means you have churn customer, okay? So on the right side I have monthly charges here, on the left I have total charges, and here I have, I think, the percentage or something like that. So you can see here the ID is this guy, a customer with the ID this, and X meaning monthly charge is 85, Y meaning total charge is 851, red meaning he is a churn customer. He has left. So this is another interesting plot. Now we'll get to this part, which is basically the missing part from the next previous session. So we are going to do some data processing. It's pretty straightforward. This is the same step which we did before. That sixth number is that here on the line categorical columns. So what we are trying to do is, as I told, the model will be comfortable if you just give it ones and zeros instead of male and female. So we are trying to do that all for the categorical columns. So wherever there is 3 categories, you will do 0, 1, 2. If there is 6, you will do 0, 1, 2, 3, 4, 5, 6. If it is just male and female, just do 0 and 1. Right? So that's what is happening here. Then we have a label encoder. Basically, it's a sklearn's API, which basically encodes your label. Then there's one more step. So one thing is you can work with the real values that is given in the data, right? If the values are something like 1, 2, 3, and 50, 51, 52, right? Or you can work with the scaled down version of that. So what does that mean? So scaled down is, instead of making it 1, 2, 3, I'll make it something. So you can see the scales are far off. Few points are here, few points are here. When what I do is I try to normalize them using some distribution. They will try to come closer. The value will still remain the same. So for example, the gap will try to bridge. The significance will remain the same. So this guy is 50 times 50. Like 150 is basically 50 times 1, right? When I bring it down, that's what basically means this, what do you call, scaling numerical column. So when you have columns of monthly charges, it is starting at 1000 and ending up at 50,000, right? So instead of starting at 1000, why don't I start with 0.1, 0.2?
Calculate equilibrium distance.
Exactly. So it gets easier to make computations. 1000 into 1000 into 1000 will maybe become 0.1 into 2 into 3 will be 0.6. It's basically making our life easier. Right? Computation is easier. It will become a faster for us model. So that's what is happening here. So it is happening in 2 steps. So we are just trying to scale them first make it work on that data frame separately, and then we are just going back and merging them to the main data frame. So what do you mean? Where are we merging? Because we have two types of categories. One is categorical values, one is numerical values. So you won't scale categorical values. 0 and 1, what will you scale? It is going to remain 0 and 1, right? But the category numerical values 1000, 10,000, 50,000 should be brought down to 0.11 something. Okay? Then we are going to mix these two to get back the original one. Okay, these are the data manipulations that are happening. This is just another simple plot, which is, I think, is not necessary. What we are doing is once we have done the so as I told you, the describe of the pandas doesn't consider categorical values, right? But this function is mainly giving you the categorical values also. The mean of 0 and 1 would be 1.5. So basically it's that. That's what is happening here. So you can see that that's happening. So this is a interesting plot that is important. As I told you, the Pearson correlation that I computed, right, is from this code. So it's, you can just see, so the map that I've shown you, the green color and yellow and all, it's called a heat map, right? So it is considering a lot of things, right? So 21 rows are here, 21 columns are here. So this will be always one. Like diagonal is always one. That is pretty straightforward. You're trying to see which are blue, which are going in opposite directions, and which are +1 or close to 0.6, 0.7, which are going in parallel. So that code is this, right? If you want me to go down, I think it will be just explaining one line by line, but I think you guys should be able to understand. So core is basically getting the correlation. So Pearson correlation mainly works between two distributions, which is, I think last time I explained you the formula, which is covariance of x into covariance of y. Covariance of x and y together divided by standard deviation of x into standard deviation of y. Right? So standard deviation is basically how far your values are from the mean. Right? So it's clear, right? So that's what is happening. You have these functions which are given by scikit-learn, or pandas directly will give you .core. So that is happening. So you guys can go through this, which is pretty np.array. So if you want to create a numpy array from this, basically you will try to create that once you got the correlation, right? So then you are using those values and creating the heat map with the title as Pearson correlation. The layout, the colors are on that block, which is height is 720, width and all that are basically the tick font and all that. X-axis, Y-axis, all those values, how thick they should look in the, all these things are given here. It's just basically a plot. So these are the values that are given here too. So we also define how thick these should look like, what are the color that we are using, all those things are here. Right? So I'll skip this part.
Hello?
Yeah.
Yeah, actually that correlation plot, can you go to that place, that block?
Yeah.
There, I mean, I have seen that you have calculated the correlation for partners, and I mean, those are categorical things, right? Why we are calculating the correlation for the categorical variable?
We can actually skip that. So that's not necessary. Yeah, you are true. We can actually see the, I mean, in fact, we will see the correlation between the distributions like you have told. Yes, that is true. Here we don't necessarily need to see the categorical, the correlation between the categories. But I just wanted to see the plot, how it looks like, and I've done for all the columns. So that's the main reason we have all these 21 versus 21. So we have extra information here which is not needed, but yeah.
Actually, for categorical variable, can we go with the chi-square test?
Yeah. So here I have only computed correlation. Pearson coefficient. Yes, you are true that for categorical, the better metric would be chi-square. I agree with that. So maybe I should have done that actually. So this plot actually only shows Pearson correlation right now.
Okay, well.
Does that answer your question? Or you
Yeah.
Sure. So next we'll go. We'll skip this PCA for now. Let's go to the model building. That's what we are all here for. So I'm using sklearn, so scikit-learn, which has all the models. The first line is basically train, test, split, which mainly deals, which is a function which is given to us by scikit-learn, which is very helpful, where you can just give the percentages, like 70% I want training and 30% I want testing. So you'll just give that numbers and it will directly split the data, basically randomize it, make sure all the distributions are still holding true. Right, when you are making a test and split, you might end up making an error of selecting only one category. Right, so the test and training should also contain churn and non-churners. Right, what if your test only contains non-churners? Your model is not correct, or it will just give 0 or 100% accuracy. Right, so this is a good function which is more advised to use. It will make sure that the distribution that is present in training is also holding in test. Okay. Next, you have logistic regression, which is pretty straightforward. Then you have confusion matrix, the confusion matrix that we will be using to see how each model is doing. Then you have accuracy score, classification report. So classification report also has more information, including confusion matrix, F1 score, all those metrics, right? So then you have ROC, then you have F1. So ROC is mainly receiver operating thing. That curve. So we have a 4 or 5 graphs which actually compares models, how each model is doing with the given data, right? What else? So on this line splitting test, I'm just doing 0.25. So 75% is my training, 25% is my test data. Right? So the random state is something like in a random function, you need to start with a random state. That's called like an offset, where your the takeaway here is to have the random state, which will basically so you're trying to pick randomly, right? So you don't want to end up like doing the same thing again. If your starting point is different, your random will end up somewhere else. That's the use of random state. What else? You're just filling those dependent and independent variables. Okay, so you have train under x, test under x. So x and y, which is basically dependent and independent variables, right? So you have your columns, which is the column names. Very. Yeah, I think this is not necessary now. Discrimination threshold. I think we can just skip that for now. We don't need that. That's a classifier from a company called Learnbay. One function from that, similar to plot.ly. Instead of matplotlib, I'm using that, right? So I think this guy is some other company's method that I'm using, or some package that I'm outside these standard packages. I think that's not really required now. So here I have a generic function, right? So the one idea here is to type the model again and again, create or split test and data again and again. Similar to our bar plots and pie charts, instead of creating code for everything, I made a generic function where I'm sending me the column name, so it will give me a plot. So similar to this, I have a generic function called Telecom Churn prediction, and here I have a few set of algorithms that I have in my mind. I'll call this function with that name and the parameters that it requires. Right? For example, if it is SVM, it requires learning rate. If it is decision trees, how many decision trees, how much deep I should go, all those parameters with the name of the algorithm that I'm going to use. Right? So the first algorithm there is that training X and all that, and then you have your threshold plot. Basically, if the threshold plot is true, it will be, there is a plot for that model that is returned towards the end. Suppose you just want to see the numbers, you don't care about the plot, you can just make it as false, right? So in sklearn, it is pretty straightforward and easy. If you want to use logistic regression or SVM, all you have to do is scikit-learn, import SVM, and then you do svm.fit training underscore x and training underscore y. So that will give you a model. So that's what is happening there. So that line is computing a model among all these codes. Only that line is doing that, right? So then you have your predictions. So dot predict function, which is present inside the model, will give you the predictions. Okay. What else? So towards the end, I have the confusion matrix. I have the ROC curves. I have the AUC curves. AUC curve is basically area under curve. And then I have my heat maps. Then ROC curve plot and then coefficients. So here we'll see that I'm calling this function, right? Now I have, so okay, I'll just go through from the top again. So what I'm doing is I have a generic function called this Telecom Churn, where whatever the algo is, I'll fit that with its particular parameters, hyperparameters. Then I'm basically getting the predictions. Then I'm basically getting the plots, basically classification report, then accuracy score, then testing probabilities, all these things, area under curve. Then I'm doing some plots so that I can actually see which model is performing better, right? So that's basically till here, this part. Now, so training X is basically, where is that? It's on the top right here.
We're getting the matrix.
So from that, you will make a split data. Yeah, okay. So data is 100 points. 100 points has customers X, which has 20 rows. Y is basically the dependent customer churn, yes or no. So X basically means your independent variables. X basically means dependent variables like gender, monthly subscription, all those 20 rows. Y basically means that yes or no customer churn, which we are trying to predict. Is that clear? So first, okay, I think it's important. So 100 is a data set. 100 has 21 rows. 21th row is Y. Okay, remaining everything is X. Is that clear? Now out of these 100, 25 I made as training, 75 is 25 I made as test, 75 is training. Now this portion let's focus. So this portion again has X and Y, right? So this is training underscore Y, the last one, training underscore X. That's 75. Now ignore that 75. Similar concept, training underscore testing underscore X, testing underscore Y. Is that clear? So these are the values which would be training underscore X and Y will go to fit. Where is fit? Training underscore X. We are trying to build a model using training data. Testing underscore Y and X will go for predict.
Only X will go, right?
Correct.
Yes.
Y will compare to see how well it is doing for error.
Yeah.
Right?
We're comparing Y prediction
With the real one.
real one.
Right? So I think it's clear, right? Any doubts? Right?
Hello. Yeah, actually, I wanted to ask that. I mean, are we checking anywhere whether our data is biased or not? Because these things will fall flat if our data itself is biased.
Mainly that is done with the help of plots I have here. What can you elaborate more on bias? What do you mean by bias?
Like, is it biased towards the churn or is it biased towards the non-churn people? What percentage of churn or non-churn are there in our data?
That I've shown you long back. So here in the first plot itself, we can see that. So this is the first plot. I see 26% are churners, right? The customer attrition in data. 73 are not churners, right?
So in that case, we have to do some kind of undersampling or oversampling before making the model, right?
Yeah. So that is there here below in SMOT. Are you familiar with SMOT?
No, actually, I have heard the name of it, but not.
Okay. So this, I was about to go there, but I thought, okay, I'll include that also.
Okay.
So you can see 5.2 right here. So I'll explain you what SMOT does. Let me just finish this part. We are almost there, right?
Yeah.
Okay. So thanks for bringing that up. So I'll just talk about that in maybe a few minutes. Why? So his point is that uh, actually, to answer you itself, we would require SMOT when the percentage is around 90 to 10 or 92 to 8% or 95 to 5. So what are these values? 95 is the customers that are with you. Only minor portion are leaving out. 5% are leaving, right? So the model always will do 95% because the 5% is so small for it to see, right? It will miss out, right? That is basically bias where he was mentioning. So when leave 5%, I was working in one classification problem where it was 0.01%, right? So there are 4 classes, A, B, C, D. A is 1000, B is 100, C is 20, D is just 5, right? So model can never see these 5 points compared to this 1000. Total points are 100 plus 1000 plus 20 plus 11, 25. But the categories, you see the distribution, right? So that's the main reason I was going through the plots, why we do the plots, right? To get a sense of what we should go next step. Because all the models, when you do predict in this manner, will always have 90% accuracy or 99% accuracy. These 5 also will come as 8, right? These 20 will also come as A or B, right? So the mistakes that you're doing are what? 25. But they are very important to you. That's when you see F score, right? In the last session, I was emphasizing why, I think you only asked why you should look at F score. Here we have a healthy distribution for models to learn, which is 76 and 24. What if the model is like 98 and 2%, right? So 98 is might as well making a model, everything is customer, yes. You'll just make 2 mistakes there for 100. But that's not the goal, right? We want to hunt those 2%, right? So in that cases, what we do is we do oversampling, or we undersample the 98. So we have 98% of label, which is customers who are sticking with you. Why do have 98%? Let's just bring it down to some percentage and increase these guys, so that the model can make healthy pattern and try to see it. No matter what model you use, when the percentages are in this way, 98 and 2% or 99 and 1%, or it model will always try to predict the 99 category. It will always say, because you are making an error of 1%, so model is fine with that, right? But your goal is to find those 1%. So you will apply several other techniques. One is undersampling, okay? The majority, which one had 1000 in my case, we will undersample it to maybe 500. So what does undersampling mean? Can you just remove 500? Maybe I can ask you, maybe I can make it a Q&A now. So can I just remove 500 in my case? Random, okay. Can I just remove first 500? What is the problem? Is it okay if I just remove? In my case, I had, okay, I'll explain my question. I had 4 labels. A, B, C, D. I'm trying to classify when a new data point comes. Is it A or B or C or D? But my problem was the A was 1000, B was 100, C was 20, D was only 5. Right? So I told you, you guys understand what is the problem. The ratios are so bad that the model will not able to find a pattern to split that 5. 5 will just hide within that 1000. 5 and 1000, it's a really big ratio, right? Now what I'm saying is I want to undersample the big one, which is A, which is 1000 points. I'm saying I want to undersample to 500. Still it is big, but I lost half of my data, half of my points. So what are the problems with that approach and how should I do it? Any thoughts? Online people maybe. Okay, I'll just give you a few hints. Can I just remove the first 500? What happens if I just remove the first 500? Or just, can I remove 2 to 502? Where will I know which one to fix? Which one to pick? You know what will happen if I remove first 500, right? I might lose some useful information about A, important information, because I'm knowingly deleting my data. Because my other label is small and trying to get it on that scale, I'm knowingly deleting a lot of 50% of my data. If you just randomly delete, it might affect your accuracy because it might lose the information that A itself holds, right? So that is a problem with undersampling. oversampling. Now, how do we make this 5 to maybe 50? One simple approach is duplicate it. Right? You have 5 names. You make it 5 times into 10. So 50 columns you'll get of same 5 names. But what is the problem with this approach? So the model might remember it. Right? We'll try to overfit that. You see the problems with that and this. Now, how do we solve this problem? So that's when we use SMOT. So SMOT basically means it will not hurt this proportion a lot, but it will try to create synthetic data in that manner itself. It won't just replicate like a crude way. It will try to cluster the data, try to synthesize new points. So that the distribution that was there before is not affected a lot. Out of those 100 points, if you say I'm removing 50, half of your data is gone. Instead, it will see from this cluster, I'll remove 2 points. So cluster remains the same. But if you remove the cluster, that's a bad idea. Let the clusters remain. Just remove few points here and there. Right? That's what SMOT basically does. So there is one approach that I'm using SMOT for accuracy. So this is the baseline model, which is logistic regression. So you can see here the accuracy of. So let's just get back to the model. So we have we are now trying out logistic regression. Okay. So the logistic regression accuracy is 0.80, and you can see the precision, recall, and F-score on the classification report, right? So this F-score is important, very important in my example where I've shown you 1000, 250, and 5. My F-score will for the last 2 will be 0, right? The model is not able to predict; it will be 0, but my accuracy is high. You get the point, right? Accuracy is good, everything looks good, but my F-score is bad. So that way you ignore that model or try to use SMOT and apply it again. Is that clear? You guys understood the problem and how do we approach it and why we use F-score, when we use F-score, why not only use accuracy? You guys have some idea, right?
In this case, more might not be required.
Not required. That's the reason I didn't go there only, first of all. Because I felt the proportion is good. 70-20 is fine. The model should predict. If it is 2%, then I am worried. That's the reason that that data is also not given to you. There are spam detection data sets where spam, how much? Or fraud, for example. 1-2% will be fraud. If the majority is fraud, something is wrong with your company. Right? But fraud, all these small will be very minute. Then you need to work with SMOT or undersample or sample, try to see how it is. In this case, I don't believe, because I think this model is right more than enough. I think how much is it? 0.8. So we are doing really well. 80% of out of 10 times, 8 times you will give me a correct answer. And your F scores are also good. You are not doing only well on customers who have churned, you are also doing well on customers who are going to stay with you also. You are doing well on both those categories. So you can see those scores there. F1 score 0.81, 0.60. Right? So you can see the confusion matrix. So I think you guys have a sense now of the complete flow from the data cleaning, from the manipulation, from the plots. Right? So the plots are important because, as we brought up, why are you not using SMOT, or is there bias in your data? How do you know that? You cannot go through all the scroll the lines and it doesn't make sense. You need to plot it out. Right? That's why I plotted that first curve, and that's why I included in the PPT showing that it's a healthy data. We can do well with the model. Now, when in my case, the categories where I had that bad distribution, like 2%, 1%, F scores were 0. Then I'm worried. Now, what should I do next? Here, F scores look decent, so we can go ahead, right? So,
what is the range of F score?
0 to 1.
No, F score.
Sorry?
What is the good range? Means more than 70 or 60?
Okay, so F score is basically harmonic mean of precision and recall. I am not sure how how are those values correlated. So okay, let's see. This model is giving these values. Let's see if any other model is giving better values. That way we can see how far it can go. Right? You also have to remember, don't only look at F-score. First look at accuracy, then look at F-score. Right? Not the reverse. Right? What if you're doing all the mistakes? F-score is good. Right? In fact, actually, F-score actually encompasses everything. Let's see. So this is the LR model, logistic regression.
So I will not try to find out the variable importance of variables.
So that is done here, no? In Pearson coefficient. Oh, you mean on a each granular level, which is more important to which. So here I am actually going through with the 20 columns in the X. So if you do I think that's your question of R, something you do recursive feature elimination. What is that?
Recursive feature
elimination. So what happens in that is, no, I'm not doing that here. So what I'm doing is, so let's talk about what he tried. So here I have 20 columns. Are those 20 really necessary? So your point is mainly or loosely computed related to PCA, where you reduce the dimensionality, right? My dimensionality of X is right now 20. I'm happy to use it, and I'm using it, and I'm getting 80%. That's fine. But what if you have 200 features? 20 is fine for now, right? For the data set that is given to you, and everything looks happy now, all happy. But what if I give you 200, 2000 columns, right? There's a industry where it is collecting 2000 columns about each product, right? Then you cannot give those 2000 here and cannot compute 2000 Pearson correlation versus 2000. It's going out of the window, right? Then you would use some techniques like feature eliminations, where you will see out of those 2000, how many are really important to me, right? I could have done this model only with monthly charges, tenure, and total charges. I am pretty sure that my RFE will basically end up giving these three. You get the idea, right? So I'm assuming that my model is already focusing on those as its main prediction values. So if you look at the decision tree, you will see my decisions are done mainly on these values. So even if you apply RFE, these 3 or 4 or 5 out of this 20 or 6 will end up being the most important. And you will eliminate those paperless billing or the online security or online backup, which are not so strong indicators. So you can do RFE or you can do plots, either of those. So I've done plots to show or see how well they are correlated with each other, right? So from that plots, I can actually delete few columns, right? Few columns are not helping me, right? In Pearson correlation, we saw if the correlation is 0, right? So they're in another direction. One guy is going this way and another way. So you can just drop these columns, right? Anyhow, it's not going to help. That can be done. That could be actually, that's a good point. One of those steps that could be done to remove the not so strong indicators. So here, more or less, that's what is happening. So you can see these area, the between ones like payment method versus churn, are not so strong features for me, right? So one second. Sorry, that not that one. One second. So I'm just looking here, as you have mentioned just now. So you can see here, that's what is this giving me, this plot, that in between these guys who are close to the 0 or minus 1, 0.01 are not so much important to me, right? In your case, these will be eliminated. That would actually have some impact on accuracy a little bit, not a lot, like little. That in the case where you had 2000, you have to do that. There's no other goal, because you cannot give 2000 features to a model. Your matrix multiplications will go out of the window. 2000 into 72,000 rows, it is a really big computation to have, right? In that case, you would do this feature importance that model has figured out for linear regression, right? So it has figured out that there's a positive correlation for total.
Every model has some limitation of the features. Yeah, it depends.
Features are 21. We are giving 22.
For the 20, for other models, suppose if there is large number of features, then don't know that 2000 we can design.
So in that, what we will do is we will not even go to the model first. We will try to figure out what are the important features first, right? Either to EDA or either to techniques like RFE, recursive feature engineering, right? Then you will go to model. Here, model is only giving me what is important, what looks important to it between the X and Y, because we have already predicted also, right? We have training, we've made the model, we fit the model, right? Model will try to find some pattern. Now, when you are testing with the test data, when you're doing that function dot predict, it will see how well the predictions are coming and what particular column is giving more importance to what. Right? Is that clear? Yeah, sure.
We can use this one also to get that importance features also.
This automatically is that only. In case of 2000, my LR model has to go through that and give me this. But here it's 2120, I just directly gave it. When you have the case of 2000, don't go to LR and give directly 2000 features. First do some RNG, feature engineering, like recursive feature engineering, create Pearson correlations. He mentioned a chi-square test, between the categoricals, see which one are more important. Suppose there are ones which are very less importance, remove them from the data.
Very safe.
Is it very zero, like 0, 0.1, 0, 0.1, just remove them. They won't, yes, your accuracy will be decreased a little bit, but the computation at the time will be, the trade-off is high here. Yeah, efficiency will be very high. So in case of 2000, suppose I don't do that and give it here, this model will have run a lot of time. Maybe this kernel would have died, right? Even if it works, then in that case, the middle part, I could have removed using some other technique. That's the point, right? So you have your LR here.
Hello.
Yeah.
Yeah, actually, I wanted to understand that feature importance, what you have done there. So on what basis you have selected those features and you understood the importance of it?
1 second.
Is it through the, understanding the correlation with the help of, the dependent variable with the other feature?
I think it's again using
random forest, or maybe there is one of the way.
No, I think I'm using the Pearson correlation again.
Okay.
I guess so. I need to check, actually. It's a little big block of code. 1 second. So I have that here, feature importance. This is a plot. Rows is to, okay. I think this is coming from coef summary. Where is coef summary? Coef summary is coefficients, features, is coming by sort by values, coefficient. So what is happening here is, if you are familiar with how do I explain? So if you are familiar with lasso, are you familiar with lasso? Lasso regression.
Yeah.
So what lasso does is basically try to linear regression, or basically
penalizing the coefficients which are higher weight.
So in crude way, this is happening over here. So you can see algorithm dot feature importance, right? So below this coef, if CF equal to coefficients or features, that's what is happening here. So I'm getting those alpha 1, beta, alpha 2. Suppose your equation is y equal to alpha 1 plus alpha 2 x1 plus alpha 2 x3, right? So I'm trying to get those coefficients and their importances and trying to plot this.
Okay.
I can get back to you on maybe a better explanation on what is happening in detail. Right now you can see here in the code itself from the scikit-learn, there's a line called coefficients equal to pd dot data frame algorithm dot feature impedances.
Okay,
so
it automatically gives.
Yeah, so you can see that here, right?
Yeah.
So that is coming from there. There's no random forest and all that. Just the model is giving me the importances.
Okay, and one more thing I wanted to understand, if you can explain
Yeah, yeah,
related to SMOT. So how does it work? I understood that it creates the synthesized
yeah,
data.
yeah. So for me to explain, I need to go here now. Wait 1 second. I'll just show you one picture. I think it should be pretty clear then. Can you see my screen?
Yeah.
You can see me, right? So SMOT again internally uses again some clustering and then k-neighboring, and then as I told you, right, it will just try to pick the points and look at the data. Is it remaining same or the clustering is going to change?
Okay.
Does that make sense?
Yeah, I got it.
What is happening is, so these I'll just give you this link. You can go through this. So SMOT is over here. So you have blue, you have a dark blue, you have yellow, right? So there are 4 neighbors of clusters, for example. So what SMOT tries to do is create synthetic data or remove data, try to first cluster it using maybe SVC, support vector machines, and then see that when I'm removing my data or adding more data, how is this structure remaining, is it holding true or not?
Okay.
Does that make sense?
Yeah, so it is basically checking whether, I mean, after adding the data, whether my classes are still the same.
Exactly.
Okay.
So you can just go through this link. It has a really good oversampling, undersampling, SMOT examples. So if you, okay, I'll just show you how I ended up here. So just search SMOT scikit-learn, okay? The first link, imbalance learn. Okay, open that, go to the bottom. There's a last plot called comparison of the different oversampling algorithms. Just go there. You will get the clear idea. Okay?
Thank you.
Sure. So where were we? Sorry, not this. So we finished linear regression, right? So any other questions? This is not SVM and all that. It is just inside the model itself is seeing how these are feature important, how these columns are important to the dependent variable. You're not doing anything. One model inside another. Just simple. Okay. You have your precision recall. You have this. I think you can skip that. So SMOT I think is not needed now. So we also have this, as you were mentioning, right? So maybe I can share this code. You can just pick this. But for this, we already saw LR gave us 80%. So it, like as a data science or the problem or the project statement, you guys have already achieved something. You work with the data, clean the data, have some plots, applied some model, have some precision and recall, F score, everything looks good. So you can make LR as your baseline. Baseline meaning, if you don't find anything better than this, you can just go with this, right? So we can see other models like decision tree. So decision tree, right? So you guys are familiar with decision trees, right? So here, what is happening is, as I told you, as I was mentioning, that RFE will also end up giving monthly charges and total charges as the importance. So you can see the classification that is happening on left hand side. So monthly charges, and below you can see tenure and total charges. In some crude way or in some with some intuition, you can connect. These are automatically the important features. That's why decision tree is also going towards those features, right? Because that will give you the accuracy, right? So RFE also will end up giving this. Right? Makes sense, right? So I think I can just quickly go through this. So the code will be pretty much straightforward. So again, it will be .fit, or you just have these function called decision tree classifier from sklearn.tree. You import this function, you give the maximum depth. So in case of decision tree, you need to give the depth, right? How deep that tree should go, right? It should be like 3 levels, 4 level, 20 level. Based on that, it will try to see how accuracy it is coming. And then you also have these methods like Gini index. I think Gini index, I'll just take a minute to explain. So it's basically, you see, if you split based on one decision. What is the decision here? If the tenure is less than 16.5, that is a root node. You can also make the decision using if gender is not gender. Let's take monthly charge is less than $50. Now you see your tree. You have made scenario 1. You made that decision. Scenario 2. You are using monthly charge. Here I am using tenure. Now the tree that looks where the classes are more homogenic. What do you mean by homogenic? On the left node, is it so? I'll give you a simple example. You made some decision. On the left node, you ended up with male. On the right node, you ended up with female. Right? So that decision tree is better. Instead of you making a decision where the left node again has mixture of male and female, right node again has mixture of female. Again, you have to do create male and female here. You see the problem? Your depth will keep on increasing. So that's what basically Gini index gives you to help you come up with a tree of case scenario B, not A. Right? Does it make sense? Because there are so many variables to make decisions. No. So how do you know which decision to be on the root? Or that's why there are Gini index. There are a few other metrics that you can use. So that's you can see that Gini index is 0.3 here. Then you can see the structure of the tree here. So you can see what is happening. This is just a one decision tree. Let's see the accuracy. It's 0.76, right? So our baseline model is still good.
Yes.
We can just still go back to that and be happy. So decision tree is not doing well. Let's see if something else can beat this.
Hello.
Yeah.
If you can explain me one more time regarding how it has chosen the root node.
Gini index.
Yeah. I mean, like root node, how it chosen the tenure as the root, not something else.
Yeah, that's because of Gini index. Okay, so I'll again open Google. Because I do not have on top of my mind the examples.
Okay, not a problem.
So here I'll show you a simple example that will make everything clear. So here on the left you can see split on gender. Okay, so you can see on the left you can see everything you ended up with female. On the right you ended up with male. Okay.
Okay.
Is that clear?
Yeah.
Now you're on the root node. You're making another split in scenario B on height.
Okay.
Okay, if the height is less than 5.5, you end up with a mixture of male and female. If it is greater than 5.5, you end up with a mixture of female and male, right?
Yeah.
Right. So on scenario C also, you make a split if it is class 10th and class 9th,
Okay.
right? So among these three, which one you would choose?
Which is more homogeneous, the first one maybe?
Exactly. So which is more homogeneous? Because again in the scenario B and C, you need another metric to see if it is male or female, right? Here we already ended up with homogeneous mixtures, which is female and male. So the first one will have, I think, a lower Gini index or a higher one. Let me just check. Okay.
I think higher, the impurity is more. So.
Yeah. So yeah, it will have high. Yeah. So you understood, right?
Yeah.
So I think if you can just search this.
So in that way, I mean, the next level, Gini should be always lesser than the root, right?
We can exclude that one, right? Next Gini calculation.
Yeah.
We can exclude that first feature.
I need to check. I think it should be, actually, I think it should be the same way. Wait, let me just check here. Here the Gini index is 0.39.
Then it has increased.
Increased and again it decreased.
Yeah.
Okay, that is decision tree. That's not a really great model to.
First Gini index calculated tenure. Okay. So it's split it. Then it exclude the tenure and it calculate other feature Gini index. Which one is more? It is split from that feature only.
Okay, so what is happening here is, I think you made the selection for the root node comparing all of those. Okay, your Gini index, the least you could come up was 0.39. Right.
Yeah.
Now on the left and right you have now data sets. Now again you will do that process. So I think your statement may not hold true in all cases.
Okay, okay. One
Because
more thing, if this is not holding true, then other doubt is when we are trying to prune it or when we are trying to define the level, that means, I mean, let's suppose here up to 3 levels you have taken, right?
Yeah.
So maybe in 4th layer, there will be a feature whose Gini will be very high. So why we are ignoring that in that case?
Ignoring as in, so
Let's
first
suppose,
thing is we will look at the accuracy, right? So pruning will happen when your tree is overfitting, right?
yeah.
So I mean, I'm just thinking about your assumption that how do you get a Gini index more on the after you have pruned?
No, no, no. I'm saying that let's suppose on every layer, Gini can be higher or smaller in compared to the previous layer, right? So on, let's suppose on the 4th layer, which we are not considering in this example, where for a feature, Gini could be higher. That means that feature is good to split upon if Gini is higher. Isn't it?
Gini, okay, wait. So I think you're just looking at one node split. The idea of Gini is once you make this split, you are going to compare it with other splits.
Okay, okay.
Is
At the
that true?
same time on the other features.
Yeah, you do not you do not go back and see that, right? You just see once I make this split, is it looking better or is it not looking homogeneous or not? That's all.
Okay.
Then again I go down and I see I'll make another split. Is it looking better or not? I'll pick the better one.
So that means every layer is independent of
Exactly. You recursively go down and try to see that. I was also curious if its Gini is going to increase and decrease, but yeah, that doesn't hold true here itself.
Since they are independent.
Yeah,
right?
independent. Yeah.
In this stage, we are calculating
Different features, Gini, yes. We are not, how do I say, we're not doing it everything at once.
Yes.
Yeah.
Yeah, okay, got it.
Some observations also removed the first layer, right? Then Gini, the value will be changes.
Exactly. So that's a great point. So when we are creating Gini of level 1, that the root is already done. We do not include that in our Gini. We just care about how well. So at the end of the day, everyone has to remember that when we are making a split, how homogeneous are we coming? That's the idea of Gini. That's why I didn't go to the number part. Is it more or less? Should we compare it? I mean, the main takeaway is to see how your split is homogeneous and all. That's an indicator that you have a really good decision tree. I mean, like mainly decision trees don't do really well or generally they overfit. But just for the demo purposes or this project purposes, I have kept it. Because at the end of the day, you might use this for another problem or dataset. For this, I feel LR is like well and good, solid.
Okay.
Does that answer your question?
I think I understood. This doubt I had from longer time actually.
That's good, man. You should clear your doubts. Okay, so next I think we'll go to little complicated models. Let's just skip this KN and all this. What is this? So we will go to random forest. So there's a saying in ML like if nothing works, just go to random forest. So we'll just see this how it works. Again, you have some sort of, so here instead of Gini index, entropy is used. So again, similar lines where you see if the entropy is good or entropy basically means the amount of information you have, right? So there is again a metric of seeing is it Gini like similar to Gini index, which one is getting bigger? You will see some scheme with entropy and pick the split. So you can see, well, let's just look at the accuracy here. So here I think I have how many trees? 4 or 5? 10 I think. Yeah, 10. So I have a random forest which comprises of 10 trees, 10 individual decision trees. So let's just look at the accuracy part and see how well this guy holds up. Where is this guy's accuracy? I think I did not compute this. I think, sorry, I think I did not compute the accuracy of this guy. Okay, that should, Let me just check 1 second. Where is accuracy? Okay, I think I missed this accuracy part here. Okay, I think I missed that. Maybe we'll just check with this SVM. SVM is also really really good classification, really powerful algorithm among those classifications in ML. So even this guy holds up at 75%. Right, so our LR, logistic regression, is able to do really well. So our baseline model is the best model. That was baseline till now. Now it's going to become the best. So you guys can go through the code. There are like for SVM, you can tune the parameters from 75. It became 76. All this. Let's just look at these guys. Actually, wait. This is also 76. 76. I think 76 is. Yeah, they have hit the wall after 76. So okay, this is the final slide. I'll just go through. Let's just focus on the blue part, which has the longer part to the right. Okay. Random forest has pretty good, right? Let's just go to our LR. LR beats everyone out of the game. Right? LR is like Virat Kohli. So this guy comes close, but it fails on recall. The red color, right? So this guy does well on accuracy. Precision seems good. F1 is okayish, 0.59. So to answer your question, let's just check this model here. What is F1? 0.56. What is F1 here? 0.59. So LR. Even the F score is good for LR. Right? So the higher the better. I think I'll end up here. I'll end here, end this presentation here. Any questions so far?